Okay, we've got another layout of a proof for you. This one is the sum of interior measures of a triangle proof. And we are going to take a step back, look at what we've got on the board, and then we're going to go through it. So, the first thing that's important is we do have a drawing to go with what we're doing. Now, the drawing that was originally given was just this triangle, okay? So I've done some work on it. So all we had was this triangle XYZ, okay? We've got our proof table with the statements on the left and the reasons on the right, and we have our given and we have our prove, okay? So let's take a look at what we had here. We originally had just this triangle, okay? And what we need to prove is that the measures of angles 1, 2, and 3 equal 180 degrees. Well, yeah, you could say, well, you know, the definition of a triangle, they all have 180 degrees inside, you know, but they want us to prove it. The whole point of geometry is to teach you deductive reasoning. So we have to go through the steps to prove that this is 180 degrees. So the only thing that's given to us is that triangle XYZ is a triangle, okay? So the first thing I did was I drew line L and M to extend these angles, okay? M is here to help line L. Line L was drawn first, and by doing that, I was able to make a straight angle, okay? And the whole point behind that is it creates angles 4 and 5 with angle 1. So what happens is our very first statement is that the measure of angle 1, 4, and 5 is 180 degrees, and our reason for it is a straight angle equals 180 degrees. It's the definition of a straight angle, right? So the next thing we did was, because we have drawn line M to help us, okay, by drawing line M, it helps us visually make things clearer for parallel lines. Sometimes extra lines help. So line L is parallel to line M, see? And our reason for that is the parallel postulate. Through a point not on a line, only one line can be drawn that is parallel to its line, okay? That's number 2. Because of that, we now know that the measure of angle 2 is equal to the measure of angle 5, the red ones. Why? Because if you look at this, you see that by drawing those parallel lines, I made transversals, see? And as we studied earlier, when you have transversals, the opposite interior angles, like here, are congruent, right? So we have now proved that 2 is equal to 5, okay? So if lines are parallel, alternate interior angles are congruent. It's a postulate, okay? Now, because of that, the measure of angle 3 is equal to the measure of angle 4, and I made them both blue. So we know if 5 and 2 are equal, that 4 and 3 are equal, okay? Reasoning for that is the same as number 3. So that brings us to the measure of angle 1, which is orange, and 2, which is red, and 3, which is blue, equals 180 degrees, which is what we were trying to prove. Here's the orange one, here's the red one, and here's the blue one, that they equal 180 degrees, and our reasoning is the substitution principle. In statement 1, okay, we said that 1, 4, and 5 were 180 degrees. We can now, because of the substitution principle, plug in 2 for the measure of 5 and 3 for the measure of 4, so that it's measure of 1 plus 2 plus 3 is the 180 degrees. Substitution principle says a quantity may be substituted for its equivalent. So we have now proven that the measure of angle 1, 2, and 3 equal 180 degrees, and we did it by drawing those extra lines that really helped us prove with the straight angle M drawn through here, helped it become a parallel, and then we were able to go from there. So that's the layout of a proof for the sums of an interior measures of a triangle. I hope this helps you. The next thing we're going to be talking about is exterior angles of a triangle.